There's several different materials to choose from as an engineer. We could break these types of materials down into metals, plastics, carbon fiber and composites, and wood. To finalize a material for an engineering product or application, it's important to understand the mechanical properties of the material. And there's a lot of things that we can glean off of just looking at a normal day-to-day bicycle. Some of the questions the engineer would want to ask is, what kind of application is the bicycle being used for? Is it just transportation? Is it riding the BMX and doing jumps? Is it for racing, mountain bikes? Also, what price point will this bicycle be at? And then we can start to eliminate and figure out what materials we want to use on that bicycle. For instance, some bikes come with steel wheels, while aluminum would certainly be a better option, much lighter with much less rotating weight. Bicycles can be made out of steel, they can be made out of chromoly, which is kind of an in-between hybrid of steel. It could be made out of aluminum, it could be made out of carbon fiber, some bicycles are even made out of titanium. Also, given that, there's different parts that can be used for different applications on the bicycle that need to be made out of certain materials, such as the cogs in the back. If it's a mountain bike, needs to be steel. It's wearing on with a steel chain. An aluminum chain just wouldn't be strong enough to hold up to that kind of abuse. Whereas a carbon fiber frame would probably be the absolute lightest frame. It might not be the best for doing dirt jumping or freestyle riding. So there's places where you can save money, and there's places where you have to go with a certain material to provide the strength needed. The mechanical properties of a material are those which affect the mechanical strength and the ability of the material to be molded into a suitable shape. Some of those typical mechanical properties of a material include strength, toughness, hardness, brittleness, malleability, and ductility. Strength is the property of a material which opposes deformation or breakdown of a material in the presence of external forces or load. Materials which we finalize for our engineering products must have suitable mechanical strength to be capable to work under different mechanical forces or loads. Toughness is the ability of a material to absorb energy, deformed without fracturing. Its numerical value is determined by the amount of energy per unit volume. The value of toughness of a material can be determined by the stress-strain characteristics of a material. For good toughness, materials should have good strength as well as ductility. For example, brittle materials having good strength but limited ductility are not tough. Conversely, materials having good ductility but low strength are not tough enough either. Therefore, to be tough, a material should be capable to withstand both high stress and strain. Hardness. Hardness is the ability of a material to resist permanent shape change due to external stress. Therefore, various characteristics or measures of hardness, scratch hardness, identification hardness, and rebound hardness. Brittleness. Brittleness of a material indicates that how quickly it gets fractured when it is subjected to a force or load. When a brittle material is subjected to stress, it absorbs less energy and gets fractured without significant strain. Brittleness is the converse to ductility, or the opposite of ductility. Brittleness of material is temperature dependent. Some metals, which are ductile at normal temperatures, become very brittle at low temperatures. Malleability Malleability is the property of solid materials which indicates that how easily a material gets deformed under compressive stress. Malleability is often characterized as the ability of a material to be formed in the form of a thin sheet by hammering or rolling. This mechanical property is an aspect of plasticity of material. Malleability of material is temperature dependent as well. With rise in temperature, the malleability of the material increases. Ductility is the property of a solid material which indicates how easily the material gets deformed under tensile stress. Ductility is often categorized by the ability of the material to get stretched into a wire by pulling or drawing. This mechanical property is also an aspect of plasticity of a material and is temperature dependent as well. With a rise in temperature, the ductility of the material increases.